I thought you were, I thought you were dead.
No, Nick, you failed again.
Well, what happened to you?
Well, do you remember me asking you to delete that dev Kubernetes cluster?
Yeah.
And then you going ahead and deleting the production cluster instead?
I vaguely remember that.
Well, yeah. Basically, everything was destroyed, and then I was thrown off the boat into the water. But after that, I got swallowed by this shark here, and turns out Sharky's a pretty cool fellow. So, yeah, what have you been up to?
Well, I've been thinking about how we solve the problems of our infrastructure. I mean, okay, me destroying the production cluster is one thing, but the fact that it took 2 days to recreate is the other.
So, what have you come up with so far?
Well, let me show you. Oh, wow. I really like what you've done here.
Well, yeah, it's crazy where they deliver shit these days.
Well, while you've been away kind of decorating inside of this shark, I've been looking at this thing called Terraform. And what Terraform allows us to do is to provision infrastructure, but define everything as code. So previously, when we were just kind of clicking through interfaces, well, you saw the mess I made. We can now make this declarative. It's actually really easy to use. Terraform's built up of these blocks called stanzas. And this core block is this provider block, which is the interface between the DigitalOcean API and the Terraform code. All of the information for this can be found inside of the Terraform documentation, and we can see all of this in the website. I've literally just cut and paste this.
Oh yeah, like you did with the cluster name.
Yeah, right. So then what I need to do is I need to define a Kubernetes cluster. And I can do this really easy. So I'm just going to copy and paste this resource block from the documentation. It has a number of different parameters. So for example, I'm going to provide the name, and I want to call it Minecraft Dev. The region, and this is going to be the DigitalOcean region for where I want the resource to be created. The version, I'm going to use Kubernetes 1.18, and we can use different versions that are available inside of DigitalOcean. And then I'm going to specify the node pool. So I'm going to specify just a single node inside of my node pool. And I'm going to specify the size as 2 virtual CPUs with 2 gig of RAM. All of this is configurable to the settings that you can set up inside of DigitalOcean, which is kind of neat. So what we're going to do is we're going to run the command terraform init. And this is going to set up Terraform and download the provider. The Terraform binary and the different providers that are used are distributed as separate binaries. So init is just going to go ahead, it'll set everything up, and it'll download that binary. Then what I'm going to do is a plan. So a plan is going to look at my configuration, and it's going to tell me the changes that Terraform will make. So it doesn't actually make the changes, it's just telling you what they are, which is really, really useful in my case when I accidentally destroy clusters all of the time. Lastly, to create the infrastructure, what we're going to do is we're going to do Terraform apply. So Terraform apply, it's going to give us that plan again, and it's going to ask for confirmation. I hit yes. And now what's happening is that cluster is getting created inside of DigitalOcean. So you can see that inside the UI it's showing, but also Terraform is going to give me that feedback. And the Terraform CLI is going to kind of keep updating until that cluster is ready and it's available. And that'll take, well, it takes how long it takes, a couple of minutes. And that's done. So, I mean, that was relatively painless. And the interesting thing is Terraform tells me, obviously, that it's added. The Terraform command has exited, and that cluster is also available, ready up there. So we're getting that direct feedback between the DigitalOcean API, or the UI in this case, and also Terraform. It's reading from the same source, which is awesome. Now, I only created 1 node, and what I actually want to do is create 3 nodes for my worker pool. So let's have a look at how I can do that, because Terraform's got the capability to actually update in place where possible. So I could just update this node count in here, and I could change it from 1 to 3, but this is actually a pretty good opportunity to show you how to make configuration dynamic. And we do that with variables. So a variable is another stanza block, and you can see here I have a variable called node count, which is of type number, and it has a value of 3. I can do the same thing with the region, so I can set again a type of string, a name region, and a default value of AMS3, which is the Amsterdam region. To use those inside of my configuration, what I do is I use the keyword var, and then the name, so node count. And then again, if we look at how we would do that with the region, what we do is we do var, and then the region, which is the name of the variable region, and then at runtime, Terraform is going to replace those with the variables themselves. Let's run it and see how this works. So Terraform plan, and this is going to give us a plan, and you can see that we're going to make one change to our configuration. Now the change here is going to be the node count, and it's moving from 1 to 3. So Terraform is showing us all of that information. Remember, nothing changes until we do the Terraform apply, because it's the Terraform apply which is actually making the changes.
Whoa, hold on, Nick. Did you just type Terraform apply?
Yeah, why?
Well, we're doing a demo here, Nick. Nobody just runs Terraform apply. Come with me, I'll show you.
Okay.
So, do you remember our zombie Pigman assistant Barry?
Yeah. What happened to Barry?
Well, I don't know, but I was kind of missing him, so I just thought, why don't I just synthesize Barry, right? So, let me show you. It's pretty cool.
Oh, neat. Wow, Eric, that's actually pretty impressive.
Yeah, I know. Just give it a whirl, Nick.
Okay. Okay, Barry. Play my favorite tune. No, Barry. Stop. That's not my favorite song. I like,
You were saying what's your favorite song, Nick?
Yeah. You were no. So we can do Terraform apply with Barry. You were saying.
Oh, yeah. Okay, Barry. Terraform apply.
Barry,
that's not what I mean. He's about as useful as the real Barry, though.
So that's the cluster created and all complete, but what we need to do is to be able to interact with it. So let's see how we can do that, because actually Terraform can also expose some of the parameters such as the Kubernetes configuration. If we look at the documentation and we look at the docs for the Kubernetes cluster inside of the DigitalOcean provider, what you will see is it has these attributes. And some of the attributes that we can get are things like the host name for the Kubernetes cluster, the certificates, the keys, and obviously the raw configuration as well. So let's see how we can do that. And one of the things we can do with Terraform is use another type. So we're going to introduce this time an output variable. So an output variable is going to be able to allow us to interact with a piece of configuration or an attribute from a resource. So I'm defining this here called k8config, and I'm setting it to a value of the DigitalOcean Kubernetes cluster resource named Minecraft, and I want the attribute kubeconfig, and I want the raw config, which is just going to give me that kubeconfig as a string. So once we've saved the file, we can do Terraform refresh, and what Terraform refresh is going to do is it's going to contact the API and it's just going to update any of the variables. One of the variables we wanted to update was that output variable Kubernetes config, and you can see that here, that I've got all of that kube config. What I can do is I can interact with this. So I can use a command called Terraform output. So I'm just going to write a subshell with Terraform output, and Terraform output creates config, and we're going to output that to a file. So I can get that variable outside of Terraform, and I can just save it into a file. I'm just piping it in standard Unix stuff there. kubeconfig.yaml. Now what I can do is I can obviously just have a look at that, and we see that there, and then I can set it as an environment variable. So I'm just going to do export kubeconfig equals, and my local file kubeconfig.yaml. And what I can do is I can run the command k-get nodes, and I can see the nodes in the Kubernetes cluster. So I'm interacting with it in exactly the same way as you would do normally, just using, the command line tools that we've got, which is, pretty cool, I think. However, that only creates the cluster for me. What I wanted to do was to actually be able to install all of the application and stuff like that. So with a single command, I wouldn't take me days anymore. I'd just be nice and reproducible and nice and, easy.
Well, you're in luck there, Nick, because you haven't been the only one terraforming around here. We can actually do this by using multiple providers in our Terraform code. So what we have to do is set up the Kubernetes provider, and it needs a number of configuration parameters. So for Terraform to be able to interact with the cluster, we need to tell it where the cluster is and what credentials to use. Now, we can either use the kubeconfig file or set these fields individually by specifying all of them separately. And because we're using Terraform, we can actually grab those from the Kubernetes cluster we created above, just by referencing these values. So the host, that will be the endpoint from the DigitalOcean Kubernetes cluster called Minecraft, and we can do the same for the token and the certificate. Now, if we want to deploy an application to that Kubernetes cluster, we can use Terraform to create that deployment. But before we get started with that, I want to create a few variables like we did before, so we can make the code dynamic from the start. Now, we will be taking the following Kubernetes deployment, but instead of leaving it in a YAML format, we will define it using HCL, allowing us to make sections variable. We will create a variable for the Docker image, in case we ever want to update that. And we will define the port that it uses, just in case we ever want to run multiple of these at the same time. Okay, so now we're ready to add our new resource. So we're going to create a Kubernetes resource called Minecraft, and the fields that the resource contains are very familiar. Yes, it is defined in HCL, but the structure is exactly like we had before in our YAML deployment file. Now, for anyone familiar with Kubernetes, this will all be very similar. And then down here, all we're doing is configuring our application through environment variables. Now let's go ahead and apply that and see how that works. I can do a Terraform plan, and we get presented an error. Now, don't worry, right? It says we cannot satisfy plugin requirements. This is because we need to run a Terraform init. And we need to do this every time we add a new provider, because Terraform init will actually download all the required providers locally. Now, if we run that again, we can see the Terraform plan to create one new resource, which is our Kubernetes deployment, just like we want. So let's apply that. What it actually will be doing is it connects to the Kubernetes API and creates that resource for us. Okay, and let's type yes. And Terraform is creating our deployment. And the cool thing is actually that, as we can see, it's only creating our Minecraft deployment. It's not touching any of the resources we've created before. So this allows us to make incremental changes to our code. Okay, it's done already. Let's do kgetpods. And as we can see, our Minecraft server is now up and running.
That's pretty awesome. However, while you've been doing that, what I've been doing is I've just been Googling in the Terraform docs, and I think I found a better way to deal with those environment variables. So we've specified them all as individual items. However, what we can do is make this a little bit more dynamic by, well, using a dynamic block. Anyway, let me show you. So a dynamic block can read from a variable, but we're not going to use something simple like a string or a number. What we can do is use more complex variable, and in this instance we're using a map of type string. So we define it like this, and you can see that we're setting the keys, such as Minecraft MOTD and the value of HashiCraft. And those are going to be the key values for our environment variables. Then what we're going to do is we replace all of these static stanza blocks, and we're going to replace them with a new type, which is dynamic. So the dynamic block looks like this. What we do is we use this for each parameter and point it to our environment variables. And what that will do is that means that we're going to iterate over the map, and we're going to create an end stanza block for each one of the map items. So to set the values and the name, we'll just define that in the content block, and we point it to the key and the value inside of the map. So when we run it inside of Terraform, what you're going to see is Terraform will interpolate that at runtime, and it's just going to replace everything. So we're seeing here the individual environment variables as we had before, which is, well, I think pretty cool.
Okay, I have to give you that, Nick. That is pretty cool. But it doesn't solve our other problem, though. Now we have our Minecraft server running. How are we actually going to connect to it and join? We're going to need another Kubernetes resource. We're going to need to create a service. Now we can do that with Terraform as well. So we're going to grab this Kubernetes YAML file, and we're going to convert it into HCL. Now all the structure is going to be just the same, but because we're using HCL, we can again use variables. So we're going to grab the port that we had before, and we can specify that here, and we can actually use references to our deployment to populate the selector. Now, as you can see, we're grabbing the Kubernetes deployment, and then from the metadata, we grab that app. That's all pretty cool. Now, what this will do in the background is it'll actually create a load balancer in DigitalOcean automatically for us, so it'll automatically route from the outside of our environment to our pod running in Kubernetes, which is super cool. But in order for us to connect to it, we're going to need to know where it's running. So we're going to create another output, and this time we're going to grab the IP of the ingress that it'll create when creating that service. So we will actually have an IP and a port to join. Okay, so let's apply this. And as we can see, it's creating our new service. And if we go to the DigitalOcean UI and go to the networking tab and load balancers, we can actually see that it's creating our load balancer for us. And if we hop on over back to Terraform and we wait for Terraform to complete, we can see that it added the output variable with the IP that we should now be able to join in Minecraft.
Oh, that's neat. Let me just check to see that that IP address matches the IP addresses against the Kubernetes service.
K? What is this K?
Well, you know, like kubectl.
You mean kube control?
No, like kubectl.
Oh, kubectl.
Look, it's just K. Just K, okay? This is exactly why I have an alias.
Okay, calm down, Nick. By the way, are you using tabs for indentation?
Eric, just shut the up and let me do this, please.
Now, if you've been with us before, you know that Nick has a tendency to throw things away. So I think we're going to need some storage. So let's start off by creating a variable for a volume that we will then use to create a persistent volume claim inside of Kubernetes. Let me just add that in here, and we will be creating a Kubernetes persistent volume claim resource. And we can use that variable that we just set and use that as the name. Now, if you are familiar with Kubernetes, this will be no different than the YAML variant of the persistent volume claim. Now, the cool thing is, this will actually create a volume inside of DigitalOcean that'll then get mounted into our pod, so we don't have to worry about losing data anymore. Now, to use this volume inside of our deployment, we need to specify that volume on the deployment, like we do here. And let me just clean up the formatting a little bit.
Oh, left, right a bit.
Enough braces, not enough braces.
No.
Jesus,
no.
Nick, here we thought YAML was hard.
No, to the right, to the right.
Need a brace? Nope,
Yeah,
don't need a brace.
No.
Let's get rid of brace. Yes,
delete.
it's happy.
That's
Okay,
it.
cool.
Okay, yes.
And again, because we're using Terraform, we can use references to the persistent volume claim that we created before. To mount this volume inside our pod, we're going to need to create some mounts. And I want to use what Nick's shown us before, so I'm going to create a more complex variable. So I'm going to create a list of objects that has the source and destination. So where the file is in the actual volume and then where I want to mount that in my pod. So let's then again use something that Nick's shown us before. We're going to use a dynamic block for the volume mounts. And for each of the mounts we defined in our variable, we're going to set the name of the persistent volume claim, which you can grab by the reference. And we can grab the source and destination field from the value that we had defined in our mounts variable. So if we then apply this new configuration, we can see that Terraform tries to create our persistent volume claim, and it'll update our deployment with that new volume and mount data that we added. Cool. So let's type yes, and then that gets created. So as you can see, Terraform is done. And if we take a look at the DigitalOcean UI, we now see that we have an additional volume that was just created. Cool. All our data is now being stored, and I don't have to worry about Nick throwing away our entire cluster again.
Which is interesting that you say that, because what I want to show you now is how we can actually destroy everything and how we can clean it up again. So the first thing is using Terraform Destroy. And what this is going to do is this is going to go away and it's going to destroy my Kubernetes cluster, the PVCs, the services, pretty much, everything. And it's doing it all, well, it's not doing it as well as I could have done it, obviously. I mean, I'm the master of breaking things, but it's cleaned everything up. And so Terraform's showing me that all the resources have been deleted. If we have a look in the DigitalOcean console, you can see, well, it's gone from there as well. I think this is all pretty well and good, but what if we want to actually recreate this cluster? So the nice thing about having Terraform is that, well, we've got that reproducible way. So I'm just going to run Terraform apply. I'm going to answer yes, because, well, I've seen this all before. I'm confident this is all good. Obviously in production, you take a little bit more care, but hey, and that's going to go away and it's going to create all of the things like it did before. I mean, obviously through the magic of television, we can speed this up a little bit. And well, I mean, I don't have too much patience, but there you can see there, it's all done. Everything is perfect. Everything's recreated. And now we've got this, well, reproducible process. I can run Terraform apply whenever I need a new cluster. I can change my variables because it's dynamic. So I can change the number of nodes. I can create dev clusters, test clusters. And I think it's going to be really useful for us, Eric. And well, us, we kind of need all the help we can get, but I'm pretty impressed with what we've achieved here. So should we do a quick recap on what we've learned today, Eric?
Well, I mostly learned that I'm never doing another video with you again.
I meant Terraform.
Oh, right.
Well, we showed you how Terraform allows you to define and provision your Kubernetes clusters as code, and we've also showed you how you can use variables and dynamic blocks to promote reusability and keep the code clean. You saw how Terraform can work with multiple providers, so it not only can create your Kubernetes cluster, but you can provision applications for it too.
And how Terraform makes recreating infrastructure consistent and repeatable, which is very convenient when you have to work with someone like Nick.
Oh, thanks. We should probably share some links of GitHub repo where people can download all of this code and give it a go. You did upload it to GitHub, didn't you?
I'm doing that right now.
Wow. You see what I've got to work with? So this link contains all of the source code and, well, even the world that we used for Minecraft here. So thank you so much for watching, and we'll hopefully see you next time. Do you want to see if we can find a bar maybe to chill at?
Yeah, let's see if those pirates left any rum on the island. Now, I'm pretty sure I saw some rum over here.
Well, if I was a pirate, I'd hide my rum around here. Look at that.
Hey Nick, you remember when we tried to superimpose video like that? It took us hours.
Oh look, Barry!
Hey, Barry!
Wow.
Rude.
Yeah, seriously.